2.3 Basic Limit Laws. With this section, we're basically just telling you what you can and can't do with limits. I think it's very straightforward if you understand limits. And basically, we're going through what do you do when you have two items that are added, multiplied, subtracted, divided, etc. So let's start with the sum law. So if I have some limit as x approaches some value of f of x plus g of x, this must exist then it is the same as splitting them up. Okay. So we see that we can put the limit on each of them. Let me give you an example. Let's do the limit as x approaches 2, x cubed plus 2x plus 7. We're going to apply a couple other laws here too, but just for the sake, we'll show you the add part. This is the same as the limit as x approaches 2 of x cubed plus the limit as x approaches 2 of 2x plus the limit as x approaches 2 of 7. Okay. And this one we can just plug in. So 2 cubed (8, 4, and 7) is 19. Okay. You would get the same result if you just plugged 2 in here. Okay. You can just take this, plug it in, and you get the same result. Okay. This is just for your knowledge at this moment. We have to have these laws to be able to do this. Okay. It's just mathematically correct. Okay. If you get into the theory of math in college, you'll understand it a little bit heavier. Okay. This one's important. It's called a constant multiple law. The limit as x approaches some c, some value k. K is a real number. This is the same as k times the limit x approaches c of f of x. Okay, we can basically pull that out. So if I have I'll just let that one go. It's basically straightforward. So I'm going to just direct you to page 77 in your book and look at all the others. You have a product, quotient, powers and roots, all those laws, okay, that give us the ability to do limits. Be careful here. You cannot divide by 0 with the quotient, and the powers and roots. There are some qualifiers with no negative in a root. You know, a rational root, that's a fraction. No, zero the denominator, stuff like that. I'll run through a couple examples and we'll be done. Okay. Let's look at a couple of harder ones. If you look at example 1 in your book, those are plug in and just do the math. These ones will probably be the same. Okay. So t plus 6 over 2t to the fourth, the limit as x approaches 1. We're going to split it up. And then we're just going, and if you want to be math proper, you can put this limit into both of these. Now we can do it. Just be aware, you don't have to write this out. Okay. This is -1. Here is -1. This is 6. And this is -1 to the fourth is 1 times 2. So you get 5 over 2. Okay. Again, you can go straight from here to here to here. But you must show this at the least. Okay, you got to show me what you're doing there. Let's show you another one. The limit as t approaches 3, t to the -1/4, t plus 5 to the 1/3. You can do this a variety of ways. I'm going to actually rewrite it. And when you rewrite it, you do have to include this every time. T approaches 3. The limit is t approaches 3. This is the cube root of t plus 5, the fourth root of t. Okay, negative exponent goes on the bottom. That's a fourth root. This is a third root. So we have the cube root of 3 plus 5, the fourth root of 3. This is 8. Cube root of 8 is 2. The fourth root of 3. We don't know. Alright, so we can just leave it. Yeah, you can do a decimal approximation on the calculator, but it's not necessary. One more to show you, just about some of those funny properties. Okay, this is example 4 out of your book, or example 3. It's called Assumptions Matter. Show that the product rule cannot be applied to the limit as x approaches 0, f of x, g of x, if f of x and x is x, and g of x is x to the -1. So we're basically going to show that you don't get equal results. So remember that on the product rule, one of the assumptions is that this exists. So we're going to show, okay, for x not equal to 0, Okay, let's do this first. Okay, for x not 0, we know that x times x to the first, so we're multiplying the functions together, is 1. So we have to know that's true. But the limit as x approaches 0 of x to the first, negative first, is the same as that. Okay, we have to look at it on the left and from the right. Okay, if you look at the graph, if we analyze this graphically, I do believe it looks like this. All right, so from the left it approaches negative infinity. From the right it approaches infinity. Okay, so this limit does not exist. And we have a problem. All right, so we can show that the product law cannot be applied. Because that does not equal that. Okay, so be careful, sometimes you can't apply that. All right, so the assumption here was that if you look at the product rule, g of x's limit has to exist. Okay, this limit has to exist. We showed that it did not exist, therefore we can't use the product rule because that doesn't exist. Okay, so you have to be very careful. Let's get you get your workout and then we'll be done. Good old 15-minute video is not a bad deal today. One through 33, every other odd, and 26. Spiraling, 1.6, 14, 20, 22, 2.1, number 9. We will work on this in class. Have a nice evening. Toodles.